Hello class! Today we will start to learn about the anatomy of the atom, the building blocks of life, because, as we learned in the History of Chemistry introduction presentation, atoms may be the smallest autonomous pieces of an element, but they're certainly not the smallest particles in the universe. Atoms are made up of amazing little things called subatomic particles. So, what are subatomic particles anyway? Subatomic particles, protons, neutrons, and electrons, make up atoms and can be found in two main locations within the atom: the nucleus, which is found at the center of the atom, and the electron cloud, the cloud of electrons surrounding the nucleus. First, let's take a look at protons. Protons are subatomic particles that sit in the middle of the atom in a clump called the nucleus. The nucleus is composed of both protons and neutrons, the second subatomic particle we will be discussing. Think of protons as being positive because they have a charge of 1+. A good way to remember that protons in an atom are positively charged is the prefix of their name, pro. Think pro as in supporting or thinking positively about something. Proton equals positive charge. Protons are very, very tiny. One proton has a mass of approximately 1.67 times 10 to the negative 24th grams. For reference, that's about 2 septillion 994 sextillion 11 quintillion 976 quadrillion times smaller than the mass of a single grape. That's pretty small. Because measuring the mass of subatomic particles, such as the proton, in terms of grams or kilograms gives us numbers that are crazy and often hard to comprehend, scientists use a unique unit of mass measurement for atoms and subatomic particles. This unit is called AMU, atomic mass units. Very creative, right? The foundation of the AMU is accredited to Stanislaus Cannizzaro, an Italian chemist. Protons have a mass of 1.007 atomic mass units. Another important thing to know is that the number of protons in an atom is always equal to the atomic number of that atom. Atomic number is a characteristic of an atom that will refer us to what element the atom is. Every atomic number points to a unique element on the periodic table. For example, an atom with 7 protons must be nitrogen. The atomic number, the number shown in the top right corner of nitrogen, is 7, so nitrogen always has 7 protons. Here's another example. We have an atom with 92 protons. Looking at the periodic table with the knowledge that the number of protons always equals the atomic number, what element do you think is represented by 92 protons? That's right, it's uranium, with an atomic number of 92. Next up on our list of subatomic particles is the neutron. Neutrons are the subatomic particles that clump together with protons in the nucleus. Neutrons are kind of like the padding between protons. They have no charge, but have about the same mass as protons. You can remember the charge of a neutron like this: neutron, neutral. Neutral means no charge. You guys have experimented with a magnet in science class before. By doing this, you probably learned that a magnet has two sides, or poles, a positively charged pole and a negatively charged pole. In electromagnetism, it is famously said that opposites attract. In other words, the positively charged pole of one magnet will be physically pulled towards the negatively charged pole of another. On the other hand, two negative poles or two positive poles will push away from one another. This is what protons do to each other. They push away. Now think about the nucleus of an atom. The nucleus of an atom is made up of a collection of positively charged protons and neutral or no charge neutrons bound together by a force referred to as the strong nuclear force, which is the strongest of the 4 universal forces. Don't worry, you won't need to know the others for this course. It's just important that you remember that there is a very strong force created by the neutrons in a nucleus that holds the nucleus together and keeps it stable. The force keeps the nucleus from disbanding due to the protons, which want to get away from each other because they are all positively charged. Finally, we need to discuss the matter of electrons. Electrons are subatomic particles that have about 1/2000th the mass of protons and/or neutrons. We now know, because of the work of chemists and physicists such as Edwin Schrödinger, that electrons whirl around the nucleus of the atom in areas called electron clouds. Electrons have a charge of 1-. In what we call a neutral atom, or an atom whose overall charge is 0, the number of protons is equal to the number of electrons. This makes sense because each proton holds a charge of 1 plus, and each electron holds a charge of 1 minus, and neutrons lack charge. So, if an atom has an overall charge of 0, the number of 1 pluses, or protons, must cancel out the number of 1 minuses, electrons. Take carbon, for example. One neutral carbon atom has 6 protons and 6 electrons. Let's check the math to find out why that is true. Each proton holds a charge of 1 plus. Each electron holds a charge of 1 minus. There are 6 protons in carbon. We know this because its atomic number is 6, and we know that a neutral atom should have an atomic charge of 0, right? So now we can set up an equation to solve for the number of electrons in a neutral atom of carbon. 6 times the charge of protons, 1 plus x times the charge of electrons, 1 minus, equals 0. So 6 minus x equals 0, thus negative x equals negative 6, and now we know that x equals 6. There are 6 electrons in one atom of carbon. Electrons are not found in the nucleus. They actually move extremely rapidly around the nucleus in specific formations that are often referred to as the electron cloud. Here you can see an example of the electron cloud for hydrogen. The characteristics of the electron cloud of an atom depend on the number of electrons in the cloud. They will form different orbitals depending on the identification of the atom. As we said before, electrons are much less massive than protons and neutrons. Protons and neutrons have about 2,000 times more mass than an electron. Take a minute to reflect on the main points covered in this lesson. We learned about protons, neutrons, the nucleus, electrons, and the electron cloud. I hope you've all learned something new about the construction of the atom and can't wait to start a lesson on atomic mass and mass number next time.